You know, light is something we pretty much take for granted. It's just there. But have you ever really stopped to think about what it's doing? It's this invisible force that literally paints our entire world, creating amazing illusions and revealing deep truths. And today, we're going to unlock some of its coolest secrets.
I mean, you've seen this, right? You put a perfectly straight straw into a glass of water, and suddenly, it looks like it's broken. Or what about a mirror? How does a totally flat piece of glass show you a perfect, three-dimensional version of yourself? It feels like magic, but I promise you, it's not. It's just physics.
Yep, the answer to all these everyday little mysteries is light. You can think of it as the ultimate magician. It's got all these incredible tricks up its sleeve. But the best part is, they aren't random. They follow a very specific, predictable set of rules. And today, we're going to pull back the curtain and show you exactly how it all works.
All right, so to really get a handle on the magic, we have to learn the basic moves first. Let's get right into it and start revealing the secrets of how light shapes what we see, starting with the absolute fundamentals.
So what even is light? Well, at its heart, it's a form of energy, and it travels in these perfectly straight lines that we call rays. Oh, and it's fast. I mean, unbelievably fast. We're talking 300 million meters per second in a vacuum. It's this energy bouncing off absolutely everything around us and shooting into our eyes that literally creates our reality. So, what's the first big secret of light? Well, it's what happens when it hits something it can't pass through. It does something really, really simple. It bounces. And in physics, we have a name for that. It's called reflection.
Reflection is just that, light bouncing off a surface. The easiest way to think about it is like a tennis ball hitting a wall. And this simple little bounce is how we see almost everything. The walls in your room, your desk, even the screen, none of them are making their own light. You see them because light from somewhere else, like a lamp or the sun, is bouncing off them and right into your eyes.
Now, of course, physicists have some specific names for this whole process. The ray of light that first hits the surface is called the incident ray, and the one that bounces off, well, that's the reflected ray. It seems pretty straightforward, but this whole interaction is actually governed by two very precise, totally unbreakable laws.
And here they are. First, the angle that the light comes in at is always equal to the angle it bounces out at. No exceptions ever. Second, the incoming ray, the bounced ray, and an imaginary line we draw straight out from the surface, they all exist on the exact same flat plane. These two beautifully simple rules explain everything from your reflection in a pond to how giant telescopes can peer into the deepest parts of space.
So those laws work perfectly for flat surfaces, but what happens when we start to curve the surface? Well, that's when light really starts to have some fun and begins to bend and twist our perception of reality.
Let's start with the mirror you probably look at every single day. Your bathroom mirror is a plane mirror, just a fancy way of saying it's flat. The image you see is what we call virtual, because it looks like it's behind the glass. It's upright, it's the same size as you, and it seems to be the same distance away. The only weird thing it does is swap left and right. That's called lateral inversion, and it's why when you raise your right hand, your reflection raises its left.
Now for the really fun part, curved mirrors. A concave mirror curves inward, kind of like the inside of a spoon. This curve gathers up light and focuses it to a point, which is why it's great for shaving mirrors that magnify your face. A convex mirror does the opposite. It curves outward, like the back of a spoon. It spreads light out, which gives you a much wider view, perfect for the side view mirrors on your car.
So how can we predict what an image in a curved mirror is going to look like? It seems super complex, right? But physicists have actually boiled it all down to 4 simple, totally predictable rules for tracing the path of light. Now, you don't need to memorize these. The key thing to know is that by just drawing a couple of these paths, you can figure out exactly where an image will show up, how big it will be, and whether it's right side up or upside down. It turns chaos into predictability.
Okay, so we've covered bouncing. Now let's get to the final big trick that light has up its sleeve, bending. This is called refraction, and it is the secret behind our original mystery, that bent straw in the glass.
Refraction happens whenever light passes from one material into another, say from the air into water. When it crosses that boundary, it actually changes speed. And it's that change in speed that causes it to bend. That's the whole secret. The light rays coming from the part of the straw that's underwater have to leave the water to get to your eyes. As they do, they bend, tricking our brains into thinking the straw is in a different spot than it really is. And this effect is absolutely everywhere. It's the reason a swimming pool always looks shallower than it really is. And, more importantly, it's the fundamental principle that makes all lenses work.
from the ones in your glasses to the complex lenses inside a professional camera. All they're doing is bending light.
You know, scientists even have a way to measure this bending power. It's called the refractive index. The easiest way to think about it is like a score for how much a material can bend light. Something with a high score, like a diamond, bends light a lot, which is exactly why diamonds sparkle so much. A material with a low score, like air, barely bends light at all.
So we have bouncing, that's reflection, and we have bending, that's refraction. Now let's see how these two simple principles combine to create the amazing technology we rely on and the natural beauty we see every single day.
Every single time you tap your phone to take a photo, you're basically commanding refraction to do your bidding. The camera's lens is just a precisely shaped piece of glass that bends all the incoming light rays, focusing them perfectly onto a digital sensor to capture a sharp, clear image of your world.
And hey, if you wear glasses or contact lenses, you are literally walking around with the personal refraction machine on your face. Those lenses are designed to bend light just the right amount to correct for any little imperfections in your eye, making sure you can see the world clearly.
And it's not just about technology. One of nature's most incredible displays is pure optics. A rainbow is a perfect team-up of reflection and refraction. Here's what happens. Sunlight enters millions of tiny raindrops and refracts. Then it reflects off the back of the drop, and then it refracts again as it leaves. This whole double bending process is what splits the white sunlight into its full spectrum of colors.
So let's do a super quick recap of the fundamental rules. Reflection is just light bouncing. Refraction is light bending when it changes medium. And by curving surfaces, we can control all of these effects to magnify, shrink, and focus light. These simple ideas, they're the foundation of all optics.
So from seeing our own face in the morning to capturing images of distant galaxies, it all comes down to the simple, elegant physics of light, bouncing, and bending. The beauty of light isn't just in what it shows us, but in how it literally shapes our entire perception of reality. So the next time you look in a mirror, just ask yourself, am I seeing what's really there, or just what the light decides to show me?